In this tutorial, I'm going to illustrate the operation of a sequencer output instruction, SQO, in an Allen Bradley Micrologix 1000 PLC. What I have here is about as simple as I can make a program using this instruction. I have a single bit activating the sequencer output instruction. That bit is coming from a real-world input, bit number 0. Over here in the sequencer output instruction, first I have to give it a file number, or file location, where it's going to get the bit values for the sequence. And I've arbitrarily chosen binary file number 3, word 0. The mask value here tells me which bits in that 16-bit binary word I'm going to pass on to my destination. In this case, the mask value is 000F. That corresponds to the first 12 bits being all 0 and the last 4 bits being 1s. It's a hexadecimal number. The destination in this case is my output register, my output word. And what that means is it's going to take the first 4 bits, the values that I have stored in that binary file, and put them sequentially into the 4 bits corresponding to my output on the PLC. Since this is a Micrologix 1000 bottom of the line PLC, it only has 4 outputs, so that's why I'm using those 4 bits. I also have to assign a control file. In this case, R6, standing for control. I'm using the first one available, 0. And I'll give it a length, how many steps there will be in the sequence, and then you see right here the current position value. We are currently running the PLC and we are online. We see the virtual power highlighting in red here, and so I'm going to focus your attention here on the sequencer output instruction as I toggle that bit on and off. So you can watch now as I toggle a bit on and off. Virtual power is going on and off to the sequencer instruction. And you see here as I do this, the position number changes. It goes from 1, 2, 3, to 4, back to 1, and cycles around. And you can probably hear the clicking sound. That's the sound of the outputs on the PLC sequencing. So holding up the PLC here, you can see currently I have output number 3 energized. As I take my input switch, the one set to toggle the sequencer, and I move it here, you see it's stepping through a very simple sequence. First it's bit 0 energized, then bit 1, then bit 2, then bit 3, and back around to 0. I can show you where we set this sequence in the program. That is specified in file B3, binary file, word 0. So I'm going to go over here to my data files on the left-hand pane and double-click on B3 for binary. And here you can see I've set up my 4 steps. In B3.1, I have all these bits set up, all 0 except for the very last one is a 1. B3.2, they're all set up except the next to the last bit is a 1. B3, so on, and so forth. So you can see these 4 1s right there, 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 and there establishes my sequence. That is the sequence of on states that my 4 output bits will go through as the sequencer instruction steps through these 4 words in this binary file. I can change this right here. I can actually change this to a different value if I wish, change it live, and that of course is going to change my sequence as I step through. So right now I've altered on step 2 and also step 3, I've altered the sequence that I had before, and what that means is as I step through step 1, I'll be energizing bit 0. When I get to step 2, I'll be energizing bits 1 and 3. When I get to step 3, I'll be energizing bits 1 and 2. Then when I get to step 4, I'll only be energizing bit number 3. And then I cycle back around to step 1 again. So I'll close this out, and we'll see this play itself out in the operation of the PLC. So coming over here, I have bit 0 energized. Now I have bits 1 and 3, just as I changed the sequence in that binary file. Now I activate the sequencer again. Now I have bits 1 and 2. Activate again. Now bit 3. So I've just changed the sequence by altering the 1 and 0 states in that B3 file. And I can set that to any arbitrary sequence I want. The sequencers are very powerful instructions used often in industrial processes to control batch operations and other operations where things have to take place in a certain order. For example, in the food processing industries, you often see clean-in-place systems controlled by a sequencer in a PLC, where they have to open and shut valves in a certain sequence to introduce acid and caustic into the food handling vessels to sterilize the vessels. Everything has to be done in a certain order, a certain sequence, with certain timing, and a sequence or output instruction like this is ideal for accomplishing that functionality.